Okay, let us start. Hi everyone, I'm Mahimaanvita. You can call me Mahima. So today we're going to be talking about virtualized lists in React. Let us start. So a little bit about myself. I'm working as a software engineer at Optimizory Technologies, today's host. And I've been working with full stack technologies like Node.js, Express, HTML, CSS, JavaScript, and with keen interest in React.js for about 6 years now. And you can find me on Twitter, LinkedIn, and Hashnode. And this is my profile link. And we're also going to be adding it in the description box after the stream is over. Okay. Uh, so let us get into it. So, first of all, uh, so when you have been working with developing apps for a while, you'll often face scenarios where you have to be dealing with big data. So I mean like some 50,000 or 1 lakh items. So it is not the same as dealing with 100 or 50 items, because as the scale of data increases, the memory used by it also increases. So we need to take some measures to combat it. Otherwise you'll experience things like janky scrolling, uh, or in especially bad cases you will even find that the UI breaks and the browser stops responding. So this is a very common scenario, and today we're going to be looking at ways to combat this. Okay, so you must have already been familiar with these strategies because it's a very common problem. So first thing which everyone knows and loves is pagination. So it is a pretty simple concept but very effective. So let me show you an example here. So this is Links Explorer, Jira app that we have developed at Optimizory. You can take a look at it later. So here I have a bunch of a big list of issues I have to show. So when that happens, rendering it everything at once becomes a big task. So we're going to split the list into chunks and display it as pages. So here you can see like we have two pages. So the next page is going to render the next 10 items. It is a pretty simple concept, but it is very effective because, first of all, it takes away your problem of big lists, and it is very popular and very user friendly. So users know what to expect, they know how many pages are there, and they can estimate the size of the data based on the number of pages and page size. So this is a very foolproof mechanism. Okay, but there are some cases in which this becomes a little difficult to handle, because suppose you're on a mobile screen where clicking buttons becomes very difficult, or suppose you want a feed like structure where you want it to be continuous instead of manually skipping through pages. So in that case, this is we use a newer concept called infinite loading or infinite scrolling. So this is also pretty common. We see this, suppose you can see the Google search results. As we scroll down, the new elements get loaded. So this is the concept of infinite scrolling. So previously we used to, if you remember, we used to have that G O O O O G L E. So we click on the O's to go to the next page. So that was older one, and now we have this infinite scrolling, right? So this is the basic concept. But again, we come back to the initial problems only. If we don't take steps to counter the problems that come with big data, then again you're going to suppose, let us talk in terms of React only. So if you keep adding state variable data to the state variable, ultimately it is going to cause memory issues. um, and then again the browser might crash. So to combat this, we need a solution. That is where virtual lists come in. Okay, so let us talk in detail about this concept today. Yeah, so let us see how they combat this memory usage and thereby slow rendering and jerky scrolling. So I have prepared a small demo to go along with this. Let me explain via that. So here you can also access this. It is hosted on Vercel. So first, let us start with the normal list. Here I have run the performance. Let me load it. Where is it? I think in documents, virtual list, normal. Okay, so I have run the performance profiler on this, and this is the result. Okay, so you can see that. So this is the normal list. That is first. I'm just going to where is it? Yeah, so I have some 1 lakh items, and I'm mapping over each one to generate a list item. That's it. So I rendered that, and this is the performance of it. So you can see that it is taking about 40 MB of memory, and I ran it for 20 seconds, and it is taking a lot of time to render and paint, right? So now let us compare the same thing but for uh, a virtual list. So I'm going to do the same for the virtual list. So I ran this also for 20 seconds, and you can see the clear difference in the time and in the memory taken. So you can see that it is taking maximum of 17 MB, where this is taking 40 MB, right? And similarly, the nodes rendered, this is rendering a lot of nodes, and here you can see maximum it is rendering only these nodes, right? And you can see a significant difference in the rendering and painting time. So the it is clearly visible how this virtual lists are helping. And you can also run the lighthouse on this, and you will see that the initial loading time is also significantly improved by using a virtual list. So that is what we are going to learn how to do today. So how can I improve this performance like this? Okay. Yeah. So by the way, we are going to have a Q&A session at the end. So please write your questions in the chat box, and I'm going to be taking a look at them at the end. Okay. So that is how they help. Okay. So now let us get into the implementation of how we can make this work. So first, let us understand the concept. So here, assume that this is a big list. Okay. So this all of this is a big list, and like we took like about 10,000 items or 1 lakh items. And the important thing to remember is no matter how big your list is, so my list is 1 lakh items long, but at a time I'm seeing only 12, right? So what I want to render, so this the way this virtualization works is I'm going to render only those items which are currently visible on the screen, and I'm going to leave place, just render some empty space for those which are not. Okay. So the way this works is, first we identify a window, a rendering window, right? So that consists of the visible screen. So this is the visible screen plus a buffer. So suppose 10 items. So I will render 10 items above this list and 10 items below this. This is item 1, it won't have, but still. So yeah, so I'm at item 92. So I'll render from 82 to 114. So that is going to be my rendering window. Okay. So first we identify that, and as the user scrolls through, we are going to simulate in such a way that the rendering window also scrolls along, and we are going to render only those items which fall within this window. So we are going to calculate the scroll positions, and we are going to identify which fall in this threshold, and we are going to render only them. So that is why when you see this performance optimization comes, because at a time I have 10,000 items but I'm rendering only 15. That is why you're getting so much uh, free time here, right? So let me show you practically also. So so this is my normal list. If I go to the elements tab, and if I click on this one, you can see that 1 to 500, and it shows me that there are 99,500 items more. Okay. But if you see the elements tab of this one, what does it show you? It shows only item from 1 to 15. So what about the rest? They haven't been loaded yet. If I scroll through, you can see that the previous ones are disappearing, and now I have items from 209 to 225. So as I keep scrolling, the list values are getting updated, but new DOM elements are not getting added. So we are I hope you can correlate between this concept and the one which I showed you practically. So this is a very interesting optimization technique, and this is the concept behind it. There might be different styles of implementing it, but this is the concept. Okay, so I hope this concept is clear. So now let us actually get into coding. Um, and we are now going to build a virtualized list from scratch. And then we are also going to use a package called React Window, which handles all the edge cases and gives us a lot more other facilities also. Okay, okay, then let us start. So I have created a demo for this, and it is I also have a GitHub repository which you can clone. We're going to put that links in the description box, so you can take a look at it later. Fine. So let me run this first. So here we have localhost 3000, and let us look at, yeah, I already discussed the normal list, right? It is just plain rendering. Now let us look at this implementation from scratch. So this is a starter file for that, and this is normally so I'm rendering only 100 items the normal way. I'll show you the code. So static virtual list page and list. Yeah, so by I'm generating 100 items so that my user doesn't use my browser doesn't crash while I'm explaining this. I'm going to render only 100, and uh, and I'm going to render a list component and give it all the props it needs, like overscan. Overscanning is the padding which I told, and window height, the visible window height, this one, and item height, the height of each item, and all the, so here I'm just using some placeholder static items. So this is all the list of 100 items, and the component to render, the list component, yeah, the div whatever to render. Okay, so now we are going to take a closer look at this list component. So what I'm doing initially is I have this generate rows function, and it is going to map over a slice of the list and render all the items there. Okay, so initially the start index is 0 and end index is list dot length. So the same as previous, it is 100, 1 to 100, it is rendering all of them. So now we are going to improve this. So I hope the starter file is clear to everyone. Okay, with that in mind, let's get started. So the first thing while optimizing something is, what I think is, my optimization should not cause a bad user experience. So there's no point in that. So what I'm going to do first is, let me comment this out. So first, no matter what happens, I want this height to be consistent. So I'm going to say, I'm going to give this a style property and say list dot length into item height. So maybe this does not have background color, that's why it's not showing. Let's give it a black background color. Yeah, so this is our list dot length is 100, so 100 into 40. So this I'm able to scroll freely through this, and this experience should not change, but the items should appear as if they are natural. So this is the starting point. Okay, so now let us focus on the items generated. Okay, so first thing what we need to do is, we need to identify what is the start position of my slice, and what is the end position of my slice. So how we will determine that? So if you see, normally also in any normal list, what determines which item is the starting item? The amount I scrolled, right? So if I scroll a significant bit, my first item is not going to be 1, it is going to be 146. So who is determining how much what is my starting index? It is the scroll position, right? So what we need to track is the scroll position. So let us do that. So first I'm going to create a state variable here to track the scroll position. So I'll say scroll top, set scroll top is equal to So initially it is going to be 0, right? And now let us attach it to the parent container. So I have this on scroll method. It is going to set the scroll top to the current target means this only, and it is going to set the scroll top of this list. Okay, let us log this value so that we can see what is exactly happening. So let me refresh. Okay, sorry, this is not localhost. Let me see here. As I scroll through, you can see my scroll position, right? So we are going to track this to determine our first starting index and ending index. Okay. So now my value is present at scroll top. So now let us comment out this one, start index. So now how we will find the start index? So this is actually a simple math. So what we're going to do is const start index is equal to, so what is the starting index? So the amount I scrolled divided by the item height will give us the starting position, right? The starting index. It should give us, there is a lot more, but that is the starting point, right? So let us write that. First is scroll top by item height. So, but we want this to be a whole number because it is an index. So I'm going to do math.floor. And math.floor because I want it to be as less as possible. So I'm going to be using math.floor here. Okay. So next we have to accommodate for the buffer also, the padding. So if it is at item 81, I want to start it from item 75. So this elements is, let us call overscan. So I'm getting this prop from the list here. It is saying 5. So for the first element, I want 81 minus 5. So I'm going to say minus overscan. Okay. So, but again, suppose I'm at item 0 and overscan is 5. So, my starting index can't be minus 5. So, we are going to set a minimum also. That is maximum. So, maximum, it should be 0. If any negative values are there, we should just give it to 0. Right? So, this will be my start index. So, similarly, I'm going to find out my end index also. Okay, so const end index is equal to, so here what will be my my end index? So the scroll plus the container height will give me my end index position. So first of all it will be, and I wanted to get the maximum one, so I'll say mat dot seal of here I'm going to say uh, okay, wait, let me write it here. So mat dot seal of scroll top plus window height, and I want the next elements will come below it, so I want to say plus overscan, and don't go more than the item list length. So I'm going to say mat dot min of list dot length comma uh, the actual value. Okay, so this gives us, okay, mat dot, what happened, main. Okay. So my start index is this and my end index is this, accommodated for the buffer also, right? So now um, let us see how it looks. Okay, so this is my correct file and I'm going to re-render it, reload it. So you can see that it is still it is causing some problems. Let us see why it's happening. So first I'm going to see whether my UI React one is working fine or not. Okay, fine. So here what is my start index is math dot max or 0 mat dot floor by item height minus overscan, and end index is mat dot min of list dot length scroll top. Acha, fine. By. Okay, okay. So mat dot min of list dot length, comma, seal, scroll top plus window height divided by item height plus overscan. Now let us see. Okay, now I'm seeing item 8 from my thing, and it is looks like it's loading correctly only. So it is showing me the same 15 items, but I can see that after some time this UI is breaking. So why is that happening? So let us look at our theory again. So first thing is we need to set the window and along with the buffer that we have already done. But the next point is to scroll this window along with the actual scroll. So that is important because it is rendering 19 to 42, but 19 is the first element and I have scrolled through so much, so 19 will be rendered somewhere here, but I want it to be here. So what can I do for that? I need to this whatever the container is there, my rendering window is there, I need to translate that also to my starting position. So I'm going to translate it to the start index into item height, which will give me the starting point. So let us try with this now, right? Okay, wait, my system is slow. So now when I reload this, I can see that it is rendering as intended. Yeah, so this is the basic concept. I hope this much is clear to everyone. Yeah, so this is the basic concept. uh, okay, so now that we have seen how to implement it from scratch, but this works only for our use case, right? There might be other use cases where my layout is horizontal, or I'm dealing with some more complex data. In that case, it is better to use a more foolproof library. So there is a dedicated library for such use cases, which is a React window. There are many more, but let us take a look at React window today. So yeah, I have another starter file for that. Let us take a look at that. Mm, this is virtual list with React window. My starter file is just an empty div. So where is that? Virtual React window page. So here what happens is the list component which I just wrote, something similar to it is given by React window, right? So we are going to use it instead of my own implementation. So I'm going to say list and I'm going to give it all the props it needs. You can read more in the docs. I'll also attach the link to it. Basically it requires the height of the window and the number of items to render and each item size, right? So after this, so an important thing to note here is whenever you are working on your own also, see that this item is going to get the index, but the content is in our hand only. So based on the index, I'm going to fetch the actual content and render it, right? So now we're going to get the same result as my own implementation, but now the list is from coming from React window. It is as simple as that. Yeah, okay. So this is the basic concept. Yes. So I hope it's clear till that. So now let us look at more example, a better example, not better, a more real world like example. So generally when you're dealing with the big list, you're often going to have to deal with asynchronous data, right? So you're going to get some data from API. So how are you going to handle this? So this is where infinite loading also is going to come in. Okay, let me explain with an example. So here I have a normal asynchronous list. Let it load. right? So this loads a list of hashnode posts. By the way, hashnode is a platform where you can write your own blog posts, and I'm going to use their API to get my point through. Okay, so now I clicked on load post and it loaded 10 posts, right? So when I click on load more posts, it is loading 10 more. So as I keep on clicking, it is going to add more DOM nodes and cause all the problems we have discussed before. So how do we combat this? So here what I'm going to do is I'm going to take a help of this package called React Window Infinite Loader. So this is a wrapper around React Window for which is particularly tailored for this use case, right? So let me show you in action. So here what I'm going due to time constraint, I'm not going to be loading writing all of that, but I'm going to show you my implementation only. So here they by the way they also have a code sandbox of a running example which is very simple to use. I recommend you go through it also. So here basically I just have a GraphQL query and I'm getting my posts and data as it is, and I'm going to give all the props to this wrapper component. So I wrote this wrapper component for the infinite loading for it to consume the infinite loader. So first thing, we are going to import the list from React Window as usual, and then we're also going to import this infinite loader from React Window Infinite Loader package. So here so this is the list which we wrote previously also. For as in React Window we are going to write everything, and we are also going to wrap it with this infinite loader package. Okay, and we are going to give it the function to load more items and loading props and everything. And so this is how it is going to look. So now initially it started loading, and as I go to the end it is loading more and more, right? So this is the implementation for this is how you would do handle something that is asynchronous but big data while using infinite loading and virtual lists. Yeah. uh, so that is about this. And now let us take a real world example of this. So Twitter is a very good example. So here let us inspect the elements here. So I'm going to study this post. um, so I have one, and as I scroll through, you can see that as we have implemented, they are also updating the DOM elements. And as I scroll at the end, I'm getting a loader and it is loading more and more posts. So it is the same concept which we have studied. So yeah, I hope this was interesting to see. You can see that, yes, and by the way the way of implementing it might be different. For example, a React Window uses absolute positioning of each element, but the concept is the same. Yes. Yeah, so that is about the example. And yeah, so that covers pretty much what I wanted to, and I wanted to give for next steps which you may want to do. So first thing is we have a lot of other packages built over React Window, so like the one which I showed you just now. And there are packages that are tailored for rendering a tree layout also. So some same big data if I'm getting in tree format, then we might need to do more calculations. So react so I'm not able to recall the name, but there is a package for that. And oftentimes we are going to get data that is different in heights, right? So the solution which we have implemented, it is only for when each item has the uniform height. But we, even with dynamic heights, the calculations should be tailored to that, and React Window takes care of it for us. So I recommend you play around with it and related packages to get more knowledge. And next is there is another interesting provided for this virtual list. It is called Tanstack Virtual. You can take a look at that package also. And yes, so I just wanted to give another insightful point out to another insightful read. So this blog post helps you write your own virtual scroll, which like we have just done now. So when you get some time, do take a look at it. Yeah, yeah, that brings us to the end. Thank you, everyone, and I especially thank Divyansh and his team, our networking lead, who has taken a lot of time and effort into making this, into coordinating this event. And thank you for Optimizory for giving me an opportunity to express my views. Thank you, big thanks. And now let us um, let us move on to the Q and A. Uh, let me. Yeah, I'll keep my screen sharing. And uh, okay, we completed it by 5:30. I'm amazed at myself. Uh, I'm happy that I could keep time. It is a very big problem for me. Yeah. Uh, so yeah, I browsed through a lot of content, but you may take time exploring on your own, and you can always reach out to us. We yeah, on LinkedIn, and we'll respond to you. You can find me on LinkedIn and Hashnode also. Yeah. So yeah, so reels to real creations ask, can we create a hierarchical tree like structure within scrolling list? Yes. So as I said, we have other packages built on top of React window, which will help you render tree layouts. So Bhargav says another alternative is Stack Virtual. Yes, I've just seen that, and I was also fascinated. How are these better than flat lists? Yashardas. I'm not sure what flat lists are. I I'd be maybe a a little more context can help. Okay, flat list is a React Native thing. Okay, ultimately they're the same concepts. Okay. Yes. Yes, we can calculate the tree hierarchical tree structure. Okay, Ravina asked, can you please explain how did you perform the performance profiling? Okay, so in mm, let's go to this one. So to do the performance profiling, we go to the, so I'm using Brave here, but it is the same as Chrome. So in Chrome DevTools, we go to the performance tab and click on this button here, record button or reload button, which will also take into consideration the load time. So I click on this and I play around with this list for how much ever time I want to record. So I scroll through, do different things, maybe click on it, and then I stop it when I'm happy. And now we are going to see the graph. So so these are the times and these are the resource. So this blue one is the memory, and bottom we have the time taken. So I have done the profiling for 14,000 milliseconds, and so the rendering time, the layout calculations took 235 milliseconds, and painting is actual pixel coloring that took 86 milliseconds. And you can study the graph here. Yeah, and you can also load and save this profile. So I can save this profile, it will give me a JSON uh, file, and I can load it like I did before. So I can do this and I'll say load profile, and take the one which I just created, and it will load. Yes. Okay. Okay. Uh, okay. Thank you, Vani. Thank you, Monica. Thank you, Avnish. Thanks, Anamika. Uh, Thank you, Ravina. I hope that cleared your doubt. Yeah, thank you. Surya Prakash asks, where do you store the remaining source data which is not visible in the DOM? Okay, so the storage is still done in the state variable only. We are just not rendering those items. Hmm. Okay, so virtual Yak window. Let me go here, and I do have a state variable for this. Okay, no, I don't have the state variables. Let me go to this hash node example where we can understand more clearly. Hash node one, normal. So here I have the list of all posts. So I'm going to do console.log all posts. Localhost 3000 is this one or which one? Virtual infinite. So you can see that as I scroll, okay, this is not responding, so it is behaving like that, but still. So you can see that as I scroll, it is adding to the state variable. I'm still rendering only a few elements. So here in components, you can see that I'm rendering only 75 to 85, but they're still the data is still in state. The data is still in state. Yeah. Okay. Okay, clear. Thank you. Okay, Ravina. So Surya Prakash, I hope that clear your doubt. Got it. Yeah, I'm optimizing UI here. So memory. Okay. Mm-hmm. Yes. So Bhargav gives a very good explanation. So source data takes up memory in JavaScript. Rendering them in DOM also takes up memory. So while we aren't changing the source data, we are only rendering a slice of the source data to the DOM. Yes. Okay then. Uh, Let us stay till 5:45, and I think then we can keep. Okay. Hmm. Okay, looking forward to other interesting concepts. Thank you, Mahima. Thank you, Surya Prakash. Means a lot. On next year's. Okay. Let me see if I can. I, what is the link for this? Yeah. I just. Okay. Thank you, Dheeraj. Thank you, Dheeraj, sir. Well explained session, Mahima, with real world examples. Thank you. I just wanted to post some links. I'm not sure. Okay, this is with Optimizory. Okay. So I have shared the links to Tanstack Virtual and the blog post which I mentioned. Do take a look when you get some time. Thank you, Shubham. Okay, then I guess that brings us to the end. Thank you for a great session, everyone. And thank you for tuning in. Bye. See you again.